We are going to find the area under the curve. The equation we are using today is f of x equals 2 to the x plus 2. This equation starts at y-intercept 0, 2 and grows exponentially by x. The area we are going to find is between points 1 and 3 on the x-axis. To do this, we are going to break our graph up into 4 rectangles. Let's start with right endpoint rectangles. To find the area under the curve using right endpoint rectangles, you will draw 4 rectangles where the right corner is hitting the curve. In order to break the area up into rectangles, we must know the interval, or how wide each rectangle will be. To do this, we must find the length of the space between x-axis points 1 and 3. With a simple subtraction problem, 3 minus 1, we know that our answer is 2. To find the interval, we divide 2 by the number of rectangles we want to create, which is 4. It looks like our answer is 0.5. Now that we know the interval, we can draw our 4 right endpoint rectangles. To understand the growth of our rectangles and write our summation, we can demonstrate it using x sub 0, x sub 1, etc. Since our rectangles start at 1 on the x-axis, x sub 0 equals 1. To continue to the growth, we will add 0.5 each time. X sub 0 equals 1, x sub 1 equals 1.5, etc. We are going to stop when we get to x equals 3 because that is where our rectangles end, and this is our x sub 4 value. Let's create our summation. A summation consists of a sigma with indices on both the top and bottom of the symbol. To the right of the sigma symbol is the argument which contains the initial equation times the width of the rectangles. The index under the sigma is the number you plug in to start the argument, and the index above the sigma is the last value you will plug in. We can use the values we just found for the indices. First and foremost, for right endpoint rectangles, the index under the sigma is always k equals 1. We are left with the index above the sigma. Because 3 is where our rectangles end on the x-axis and it is our 4th value, we will use 4 as our index above the sigma. Now that we have the indices, we need our argument. 0.5 is our interval. We will plug that into our equation as the width. Now we just need the x value that helped create the curve in the first place. It looks like we're still missing the x value from our original equation. The value of this x is simply the growth of the height. Going back to our x sub values, we can see that the numbers grow by 0.5 each time. We can also see that the 0 value is 1. This gives us the equation 0.5 plus 1. We will place this equation where our x is. Now we have a completed summation. Once you solve it, you should get 10.24. To find the area under the curve using left endpoint rectangles, you would draw 4 rectangles where the left corner is hitting the curve. Endpoint rectangles, the bottom index will always be k equals 0, and the index above the sigma will be the final subvalue number minus 1. So for our problem, the top index number is 3 instead of 4. When we plug these new indices into our summation using the same argument from our right endpoint rectangles, we have our final equation. Our final answer is 7.24. To find the area under the curve using trapezoids, you will first draw 4 trapezoids for your divided areas. You will then need the process for finding each area. The formula for the area of a trapezoid is 1/2 times base 1 plus base 2 multiplied by the height of the trapezoid itself. The bases are sub-values. For example, base 1 of the first trapezoid is x sub 0 and base 2 is x sub 1. The height of each trapezoid is simply its length on the x-axis, which remains 0.5. Once you have solved for the area of each trapezoid, add them together to get your final answer, 8.74. All 3 methods for finding the area have their distinct characteristics. For left endpoint rectangles, your bottom index will start at 0 and end at x sub 3 above the sigma for this problem, but as a general rule, it will end 1 less than the final amount of rectangles. Right endpoint rectangles are calculated the same way, but the bottom index will start at 1, with the final index being the amount of rectangles you have. For trapezoids, you will use the equation 1/2 base 1 plus base 2 multiplied by the width. The answer for this will be the average between left endpoint and right endpoint rectangles. An underestimate is when rectangles are beneath the curve, and overestimate is when they are above the curve. This depends on the type of curve you have. For the curve that is shown, the left endpoint is an underestimate and the right endpoint is overestimate. Imagine a car travels 2 to the x plus 2 miles per hour between hours 1 and 3. This car would travel a distance of 8.74 miles because we use trapezoids to find the area, which is an average between rectangles, and the problem utilizes miles over hours times hours, which equals miles.